Hi, I'm Karyn Hodgins, creator of Nifty Numbers, Math Medley, and Gelling with Geometry Family Math Night Kits. And in this video, I'm going to share with you my most recent Family Math Night collaborative project, what I'm calling the Fruit of Life. Now, I got the idea for this project when I was doing research on cathedrals, and I kept bumping into something called sacred geometry. And what fascinated me about sacred geometry was the connection between geometry and the laws of the universe, specifically the geometry of the Platonic Solids and how they were derived out of something called the fruit of life. So what I'm going to do is describe the activity, and then we're going to get into the math and science and a little bit more of the sacred geometry. Okay, so I'm going to start with the activity. So participants here are going to be making these super cute circular rings like this that we're going to use to put together the fruit of life. So you're going to need in advance to gather a whole bunch of these rings. These are 3-inch rings, and I actually used plastic bracelets for this. But if you can't find these, you can use, these are macrame rings. Okay, they're 3-inch macrame rings. I'll just let you know, I like the thickness of the bracelets because with the little guys it's easier to wrap the tape around. You can still do it. Here's an example of the macrame rings. You can still do it, and their parents are there to help them, right? So if you can't find these, then these actually will work. These are just a tiny bit easier. So you're going to need the tape, the duct tape. So here's samples of some of the duct tape that I use. Look how beautiful that is. And this is actually duct tape. It's 3/4 inch, okay, width there. And I got these at my local craft store. If you have a hard time finding these, you can go online and you can type in vinyl tape. Vinyl tape is what hoopers use to tape their hula hoops, and so they call it vinyl, V-I-N-Y-L, vinyl tape. You'll find a bunch online as well. Now these here at the end I got because they're sparkly and I like sparkles. I didn't realize until the event that they had tape or paper on the other side of them. It's not a problem taking the paper off, but it became a little bit of they're sticky, but they're not that sticky. So as participants were wrapping their rings, it was a little bit more challenging for them to do that. And as much as and as pretty as these are, I probably will not use these the next time I do this. Now here's something that you might run into. This is Scotch tape. It's called Washi Tape, and you can see it comes in different colors and patterns as well. And I got this at my office supply store because I thought, wow, this is great. Why not try this? The problem with this is that it's kind of like masking tape, okay? And masking tape rips. In fact, this rips a lot easier than masking tape. So what I found difficult was using this. See, look how easily that just ripped right there. Using this to wrap your rings, it tears a lot. Unlike the duct tape, which is actually almost stretchy and much easier to work with. So I prefer the duct or the vinyl tape. Okay, so if you put the rings together at your event, you're going to need to bring a hot glue gun and the glue, and I always like to have an extra hot glue gun just in case. And then I bring an extension cord as well. And you're going to need this is balsa wood right here. I was actually looking for little dowels. Okay, that's what you're going to use to make the Platonic Solids. You can see these lines right there. Okay, so this is the balsa wood that I found. Okay. And what I did is I just used my colorful pens and I colored them because I thought it would look much nicer to have it be colorful like that, and it does. It looks really good. So I did that in advance, and here's some leftover samples that you can see of the different colors that I used. Okay, so that's what you're going to need to make the fruit of life. Now at the station I also had an activity sheet for participants to do if they wanted, and for that you're going to need to also gather some straight edges, and I just used rulers, some pencils, and I think that's it. Oh, the other thing that you're going to need for the other one is scissors, because they're going to need to cut the tape, okay, or the duct tape, yeah. Oh, and the table tent. So, and by the way, all of the table tents and the activity sheets and any of these designs you see here are available for you on our website, familymathnight.com, under the resources, hosting a family math night links, okay, all available for you. Okay, so the table tents are important because this is how the participants are going to know what to do. So I printed about 5 of these and had them spread out. We had the long cafeteria tables, so we had them spread out in the cafeteria tables. And so now I'm just going to go through this with you. So the first thing it says to do is to choose one of these circular rings. And then the second thing is to cut several 2 to 4 inch strips of patterned duct tape, and starting at a slight angle, wrap the duct tape around the ring. Keep wrapping strips until the ring is completely covered. So here I've got one of my strips already cut here. So starting at an angle is important, because if you don't start at an angle, you're going to end up wrapping the same spot the whole time, right? So kind of at an angle, sort of like that. You see that? Now fold this part down. Okay, it's going to be a little bit bumpy, but that's all right. You can wrap over those bumps. So you can see here, now I'm going to pull. I'm doing it in the opposite direction and normally we do it so that you can see, but can you see? You just pull that. See how it's almost stretchy. It's really easy to use. And then you just pull this around and you just keep wrapping it around like that. Super easy to do. See that? Easy. And then they can choose another pattern or do the same pattern. It doesn't really matter until they end up with something that's completely covered like this. And at this point, they go to step number 3, which says, hand your patterned ring to the station facilitator, who will use it to make our collaborative fruit of life, which will then be used to illustrate the 5 Platonic solids: cube, tetrahedron, octahedron, dodecahedron, and icosahedron. I need to let you know here that if you've seen some of my other collaborative project videos, you know that the little guys get super attached to their hard work and sometimes have a hard time giving it up. So if they want to take it home with them, that's okay too. They can do that. Okay, so that's that part of it. Like I said, there's an option for the worksheet. So at the bottom it says Fruit of Life activity sheet. Choose a level, yada yada. I'm going to go over that activity sheet when we get into the math part of this. But I want to wrap up this part of it by saying that one of our curriculum consultants was there when I was putting this together, and she gave 2 great recommendations. One of them was to take these and to mount them in a shadow box. Okay, then you can easily mount it on the wall. That would look fabulous. And the other thing she said was, I had some leftover rings, and she thought taking pictures and putting them behind the rings like that of the Family Math Night event would look great, and it does. So you can actually do this with the whole Fruit of Life. You can put pictures behind that if you wanted to as well. So great, fabulous ideas. Thank you, Mrs. Cuellar, for that. You could also just hang these, just like this, on fishing wire and hang them up in the office. They're just beautiful. They really turned out great, so very happy with that. Okay, so now we're going to get into the math of science and a little bit of the sacred geometry as well. So a lot of things in sacred geometry start with something called the flower of life. And at its simplest, the flower of life is made up of 7 overlapping circles, so that those circles have the same diameter, and that the center of each circle rests on the circumference of the surrounding circles. So if you're like me, you need to see what I just said, and so I'm going to take you through that. So I'm going to start with 2 circles first, because it's going to be easier for me to show you the rest. So here are the 2 circles, and they have the same diameter. Okay, and you can see here that the center of this circle rests on the circumference of this circle, and the center of this circle rests on the circumference of this circle, right? So that's how it begins. Then you're going to take your compass. Now, I just want to share that in the classroom I actually use these compasses because I find them a little bit easier to use for the students, but these work just as well. This is going to be easier for me to illustrate to you. You take the point of your compass and you put it right there on that intersection. And I'm not going to do this because I can't do it obviously this way, but you're going to create the next circle. And then you're going to put the point on the center of the intersection of those circles and create the next one so that it's going to look like this right here. So here are your 7 overlapping circles with they each have the same diameter, and the center of each circle rests on the circumference of several other circles. Now, this is the beginning, so it's called the seed of life. Okay, and what I love about this is, and what I love about a lot of sacred geometry is the symmetry. So this right here has 6-fold symmetry. It's got 6 lines of symmetry. If you fold it on that, they're going to be exactly the same. And it probably has rotational symmetry as well there. Okay, so there you go, the beginning of the flower of life. Now when you add the next iteration to that, you're going to end up with something like this. So to kind of illustrate that next iteration I did it in the turquoise color there. And when you keep taking this out and adding your circles, here you go, your flower of life. How beautiful is that? Okay. Now this is a pattern that you've actually probably seen a lot in fabrics, in wallpaper, in pottery, in stained glass windows, and if you haven't seen it, you probably will start to see it now. So I'm going to digress just a little bit because I want to share with you some of those connections. When you start looking, when you start paying attention to things, you find that a lot of things are really connected. And this is one of those. And so I want to just kind of share this with you. So look at this flower of life, and what shape is that beginning to take on? So it's actually taking on the shape of a hexagon, right? Regular hexagon. So I'm going to connect this to our circles by taking a circle and then marking a point on it and using that point right there to then, once I get the radius of my circle here, I'm going to hold the point on there, and I'm going to mark another line on there, then I'm going to put my point on that line and create another one and go around, and you're actually going to end up with 6 points on this circle. When you connect those points, you're going to end up with an inscribed regular hexagon. Isn't that beautiful? And I just love the connection between this, the circle, and then here, the flower of life, and that shape taking place as that hexagon there. Love that. Okay, so now, within the flower of life, you're going to find the fruit of life. So there it is, embedded right there, okay? And it's the fruit of life, this right here, that's made up of those 13 circles, okay? And this is where the Platonic solids come in, because it's from the fruit of life where the Platonic solids are derived. So just as a quick reminder, the Platonic solids are regular convex polyhedrons with congruent faces. Okay, so let's take one of those, each one of those one by one. So here is one of the Platonic solids. It's a hexahedron, or commonly known as the cube. So it's regular because all of the angle measurements are the same. Convex because it protrudes out. Polyhedron, so anytime you hear hedron in geometry, you're going to think length, width, and height, so 3 dimensions. Anytime you hear polygon, you're going to think just length and width. And actually, your polyhedrons are made up of polygons, and the Platonic solids are made up of the exact same, so congruent polygons. Okay, those are the faces. And this one obviously is the square. So it's made up of the 6 squares. We've got our tetrahedron, which is made up of 4 triangles. The dodecahedron is made up of 12 pentagons. The octahedron is made up of 8 triangles. And the icosahedron is made up of 20 triangles. And what's really cool is because all the faces are exactly the same, they lend themselves really well to becoming dice, okay? And there's an example of each one of those platonic solids, and we use these in our kits. Okay, so a couple of things that are super cool about these platonic solids. So if you wrapped a sphere around this platonic solid, or any of them, each one of the vertices, that's these pointy parts here, each one of the vertices would lie on the surface of that sphere. And that's the case for each one of these platonic solids, and it only works with the platonic solids, so they're unique in that way. Something else that's really cool about the platonic solids. So back in the 1980s, a professor out of the University of Chicago, Professor Robert Moon, demonstrated that on an atomic level, each one of the 118 elements in the periodic table is based on one of the 5 platonic solids. And I find that very fascinating because it's the connection between the geometry and the laws of the universe. Back in the day, when the Greeks were all studying this, you got Plato and Pythagoras. And by the way, Platonic comes from Plato. So when Plato and Pythagoras were doing their teachings, they were studying all of this. We know there to be 118 elements, right? So everything that we know in the whole entire universe is made up of those 118 elements. That includes your mountains, your planets, your DNA. I mean, everything is made up of those. I think that's fascinating too. But back in the day, they believed that there were 5 elements. So you've got your air, your water, your fire, and your earth. And then there was this 5th one called ether, or your life spirit. Okay, and the dodecahedron. So each one of these is represented by the earth and the fire and so forth. The dodecahedron was associated with ether. Now, what's interesting about that is that the dodecahedron actually has some special properties. We'll get to some of them in just a second. But Plato and Pythagoras didn't teach the dodecahedron. They kept it a secret because of those very special properties. And so they knew about them, obviously, they wrote about them, but they didn't teach them because they found it to be a very special and unique platonic solid. So now I want to get to the 2-dimensional, because you can see these 3-dimensional representations there. And so now I want to get into the 2-dimensional representation of the platonic solids through the fruit of life. And that's where the activity sheet comes in that I talked about earlier. So there are 3 levels on this activity sheet. If you're familiar with our kits, our stations have 3 levels at each station: beginning, intermediate, and advanced. And they're color-coded: yellow, green, and blue. And so I did that. I wanted to keep it consistent, so I did that here. So the beginning level is represented by yellow, the intermediate green, and the advanced is blue. So I call this activity sheet, the fruit of life, the blueprint for the 5 platonic solids. So at the beginning level, this is what they need to do. Count the number of circles below. How many are there? But then it asks them, what strategy did you use to make sure you counted them all only once? And that is super important at that low level because of something called one-to-one correspondence. So kids sometimes tend to count things over, like 1, 2, 3, 4, 5. Okay, so they may count one of the objects more than once. So we're getting them to think here and problem solve. How can you make sure that you count every one of those circles and that you only count them once? So now they're having this communication with mom or dad or aunt or uncle, whoever, about figuring out how to do that and make sure that you've counted each one of those. And hopefully they'll end up with 13 circles because there are 13 circles. And then what they get to do is take those colorful pens and color it in. And then of course that's theirs to take home as well. At the intermediate level, they're going to use straight edge, okay? to connect the centers of each of the outer circles, and then they're going to connect each one of the outer circles to the inner circle. So they're going to take the straight edge and they're going to kind of use their pencil and connect those, and then take each of the outer ones and connect it to the center one. And then the question is, what 3D solid did you just draw? And it's one of the Platonic solids. And then of course they can color that in if they want as well. And then at the advanced level, they're going to connect the center of each circle with every other circle. So it gets a little bit more complicated here. So it asks them, before you start, think about how you will proceed in order to make sure you will make all the connections. Okay, again, some problem solving, because that's a lot of connections that they're going to make. Now, once they've made all the connections, it's going to look like this. And this is called Metatron's cube. It's a two-dimensional representation of all of the Platonic solids, except a little bit of the dodecahedron. Remember I said that one was special? It is special. We'll get to that in just a second. But here's Metatron's cube when you've connected all of the centers of the circles to each to all the other circles. Now this is a What Do You Notice poster. At all of my family math night events, I have a What Do You Notice poster. I love them because they're it lends itself well to outside the box thinking. There's no right or wrong answer. Anybody on any level can say anything about it. And if they do, we have an estimation jar at our family math night events. So if they make an observation and put it on a post-it, then they get to put a second guess in the estimation jar, and they really like that. My favorite one here was a little kindergartner who came up and said, "Oh, I see a Ferris wheel." And then of course I saw the Ferris wheel too. But anyway, I thought it'd be really fun to have Metatron's cube as our What Do You Notice poster. So now, like I said, each one of the 5 Platonic solids is represented here, except for a few lines of the dodecahedron, our special, our unique Platonic solid. In order to draw that one in, okay, and again, we're getting into connections here that I love. These outside lines, you need to divide those outside lines into something called the golden ratio. And when you do that, and then you connect the lines, you will end up with the rest of that dodecahedron. Now the golden ratio, I'm not going to get into that in this video, but the golden ratio is another one of those connections between geometry and the natural laws and the laws of the universe. And you find the golden ratio everywhere in nature, in your nautilus shells. But it's again, it's the connections that are so fascinating. So there you have it. A lot of first of all, the activity, which was super fun, and it looks beautiful, and that's going to look great hanging up in the office. And the math, and then of course the science and all those wonderful connections between geometry and the natural laws and the laws of the universe. So enjoy this project.